Hey, what's up, guys? I'm Angel.
I'm Jackson, and we're here to teach you a little bit about parametric and polar equations. Alright, so let's start with the basics.
Alright, guys, so what exactly is a parametric equation?
So the definition of a parametric equation is that a particle moves along a curve C on the xy plane so that its x and y coordinates are functions of time,
With the parameter being time. Here's an example of a parametric equation being graphed on the xy plane. Our x coordinate is going to be given by t squared and our y coordinate by 4t plus 1. And this is all going to be on the interval from -2 to 3, -2 and 3 both being included.
Okay, we made a chart, a txy chart, by plugging in our values for t on the interval from -2 to 3 to find our x and y values for the graph. You should also note that not only does the graph show our coordinates, it also shows the direction in which the graph is moving.
Eliminating the parameter. Alright, so this is basically taking the two equations that are in terms of t and rewriting them in a single x and y equation. You should know the slope is given by the first derivative of an equation.
So the slope of a parametric curve is given by the derivative of the function y over the derivative of the function x in terms of t.
And the derivative of the function x cannot equal 0. Let's look at an example of finding the slope of a parametric equation. Here are the two functions, x equals t squared and y equals t cubed minus 3t.
Okay, so you would start by taking the derivative of both the equations, then placing the y derivative over the x derivative and simplify.
The arc length is literally the length of an arc. If a smooth curve C is given by x equals f of t and y equals g of t, then the arc length of C is given by this formula.
S, being the arc length, equals the integral from a to b of the square root of the derivative of x squared plus the derivative of y squared in terms of t.
If you were told to find the length of x equals 2t and y equals 1/2 t squared from 2 to 7, what would you do?
If you remembered the arc length formula, of course, all you need to do is take the derivatives and set up your integral, and as we like to say in calculus, plug and chug. Alright, a vector is a quantity that shows both magnitude and direction, and it can be written in these three forms.
Your magnitude is pretty much the length of a vector, and it's obtained by the square root of your a value squared plus your b value squared.
Here's an example. So if you're trying to find the magnitude of the vector x equals 3t plus 1 and y equals t plus 2 at t equals 3, you would plug in your t value, which is 3, into both equations to get your a value, which would be 10, and your b value, which would be 5.
All that's left is finding the square root of your a value squared plus your b value squared.
And then you would simplify. You guys are probably used to seeing your x and y coordinates in rectangular form, but polar coordinates are given with a radius r and an angle theta. So if you wanted to rewrite your polar coordinates in terms of x and y, your x would equal r cosine theta and y would equal r sine theta.
When going from rectangular to polar coordinates, what you really need to remember is that r squared equals y squared plus x squared, and that tangent theta equals y over x. And that won't ruin it for Miss Hawkins. I'm sure she has you with the rest. The area of a polar graph is given by this formula. It's 1/2 times the integral from alpha to beta of r squared in terms of theta.
You shouldn't forget to multiply the integral by 1/2 and square your radius. So I bet you guys are wondering by now, what exactly does a polar function look like?
Alright, so we'll leave you guys here with a couple of examples. Hope you enjoyed the clip.
Thanks for watching.
And you thought that was it?
Check out how hard it is to keep a straight face while making a math video. What's up, guys? We're here to teach you. Okay, we'll start over.
Alright, so what exactly is a parametric equation? Let's do it again.
And you can see here that.
Alright guys, here's I can't say that again. Here's an example of a parametric equation being graphed on the xy plane.
We like to make a chart so you can get all your points.
So as you may know by now, the derivative
That's you. You're supposed to be the one that says what the slope is. The slope is the derivative.
The slope is the derivative. How did we start this one?
We didn't know. It was the integral from a to b of the square root of the d of the what?
If you were told to find the length, the slope.
Alright, I bet you're wondering by now, what exactly does a polar function look like?
Alright guys, we'll leave. You said alright, didn't you?
That's
yeah, you did say alright. Dude, that first one was good.
I know, let's be good. Oh, I got you. Alright, get in it. Okay, now give yourself a high five.
Almost. That was almost.
Okay. That's you. You're supposed to say